Okay, let's start the session today because I don't think new people will be joining. I think you can able to see the screen. So yeah, let me start. So this is the dealing with materials data collection analysis and interpretation course live session for assignment number 3. Yeah. So first question is plot the stem and leaf plot for elastic modulus data with scale is equal to 2. Which of the following is the correct stem and leaf plot? So first, we should understand what a stem and leaf plot is. So stem and leaf plot is used to what is it? Represent the data however we have got. For example, without any processing. Like for example, if you see this example data on the side right side, 15, 16, 21 to 41, we have the data. If this has to be represented in a stem and leaf plot or in a properly arranged manner, means how we can represent. Like one way is like segregating the values like one 10 tens, then 20s, 30s, like that. So that is what here we are going to do. So the stem will always have like first one or two digit, like based on the requirement, and then for example, if you have 180 means first two digit will be there in the stem and last one digit will be there in the leaf. So if you have 10 two digit means first digit will be there in the stem and second digit will be there in the leaf. So here if you see in stem and leaf plot we have only two digits, so which means like the stem will have one digit and leaf will have one digit. So one second. Okay. So Sharmila Shiva, am I audible? Okay. So hope I will start from the beginning. I think so. You have left in between. So the first question is like about the plotting stem and leaf plot. Yes. Okay. Fine. No issues. So first question is about stem and leaf plot. So for stem and leaf plot, first what I want you to understand is what the plot is. So what it will represent is when you have a group of data, like say 1 to 100 or in between. So how to properly arrange those data, properly represent those data as it is, like however you have got, right, as it is, how to represent. So that is what the stem and leaf plot is. For example, if I have like you can see the right side, right, like if I have from 15 to 41, like I have some 15, 16, 21, like that, I have some numbers. So if I want to properly arrange and show you these data, means how I can do is in stem and leaf plot, the stem will take one digit, means first the leaf will take the last digit. Like here 5 is the last digit. If you have 185 means 18 will be there in stem and leaf will always have one digit. So 185 means 5 will be there in the leaf, 18 will be there in the stem. So I will show the next example which has three digits. Now we are dealing with only two digits. So stem here, if you can see, like here it will be arranged like tens will be arranged in one stem, sorry, one leaf, then along the stem, then 20s, then 30s, then 40s. So here if you see stem, one is there, and then 5 6, so 5 and 6 for 15 and 16. So 5 and 6 is coming, like 5 and 1 5 6. Then if you see 2 means for 20s, 2 will be taken into stem, then 1 3, again 3 6 6. So even the repetitions will be coming in the stem and leaf plot because it completely represents the raw data. It doesn't do any processing. Just it is used to just represent the data. So two times three, even like if you have 10 times 6 also, it will be coming into the picture. Then if you take 30s means 30s in 30s we have only 0 means 30 0, then 32 2. So yeah, 32 will be placed here. Then 40 is only 1 is there, like 41. So 4 and 1. So this is how we represent the stem and leaf plot. So here what they have asked is like which of the following is a correct stem and leaf plot. So first regarding the program, like first we have to read a CSV file. Like I hope you guys would have got this modulus underscore hardness.csv file in the Swayam portal. Like you just have to invoke them and using that read.csv modulus hardness.csv. Like if you have given the get working directory, set working directory to this till here means you don't have to give the full file name. Rather, you just have to give read.csv modulus underscore hardness.csv. So it will be directly taking the values in the matrix form. Like it will have rows and columns. I hope it has modulus as one column and hardness in another column. So first column is modulus, second column is hardness. That is how the raw data was. So then library okay, we have to use the GG. We are using the ggplot. I hope from your from the lectures you might have heard about the ggplot. So ggplot is an interactive way of plotting, and it has a lot of tools to present your data in a graphical way, in a more clear picture. So and it is very easy because you can add one by one elements to the plot in various layers. You can just first you can give a basic plot, then you can change the colors, then you can add x and y axis, then you can give title of that. Like that you don't have to just do it everything at once. Based on your requirement you can modify your plot. So that is a major advantage of ggplot, and it has a lot of predefined plots, predefined functions to work with. Okay, so library scales, then just to load the libraries. So library means we are just loading the already present library, and we are just doing stem. Yeah, x we have read all the values of this modulus and hardness into x variable. So we are calling the x variable this means comma 1 means it will take only the first column. So if you have given 1 comma 1 means it will take only the first column, first row value. If you give comma 1 means it will take the entire first column. What is the first column here? It is the modulus. Yeah. So here first column is modulus from the data whatever you have got, and second column is hardness. So we are taking the modulus alone because that is a question, right? So we are taking the modulus, and with the scale of 2 we are with the scale of 2 we are representing them in the stem and leaf plot. Yes. So here you can see 18 8 19 0 2 3 like that it will be represented. So okay, this is how the stem and leaf plot works. I will introduce you some more plots like before moving into the next questions, because it will be more interactive, and it will be like interesting to learn all these things. So the same whatever data you have seen for modulus values, right? Like basically they have taken from the micro hardness tester. From micro hardness they have got the modulus value and hardness value both. So that is the advantage of micro hardness. So what you can do is like if you want to represent your hardness or modulus value in a 2D plot, because this is how the plot has been taken. Like in Penn-Kruston matrix, they have taken the hardness value by indenting from one point. Like they will start indenting from here, 2, 3, 4, 5 like that. They have found a matrix and they have got the value from that. From that, so what they are doing is like they have got the modulus value. So how you can represent this is in a graphical ways, you can go for 2D scatter plot or 2D gradient plot. So where you can show them with the colors. For example, here if I see blue color means it is having the lower modulus value. So if I see red means it is having higher modulus value. If I see in between these two means like that is not like for example this gradient color means it is not like having higher modulus or lower modulus in between some value like that. So how it will be helpful if you ask me is for example if I have a if suppose I have give me a minute. Give me a minute. Yeah. So if I have only in this region all are blue means then what I can interpret is also. So only in that region, if I have a specific color like red or blue means that region alone is having higher modulus or lower modulus. That could be because of some change in physical properties such as porosity or even some third phase. So all those things like if you are a metallurgist, I'm telling. So all those things can affect. For example, if you are a civil means you can have some other material or the composite mixture can be of different composition at that point. So that can also help. So, using this 2D representation, you can bring out a qualitative analysis and easy to interpret the data. So, like that also you can do. For that, what you have to do is first you have to, as usual, you have to read the values of modulus to some variable. Here I have taken it as modulus. Then I have used the ggplot. I have already invoked the ggplot, so I have just used ggplot. The variable which I want to plot modulus. Then I am adding the aesthetics like x is nothing but the first value x, and then y is the first is y column value. I mean, I have invoked the variable's name as x starting from 1 to 100. So 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Till here. These are the 10 x values, then 10 y values of the. So how it will take is like 1 comma 0 means it will take this first value. Yeah. 1 comma 2 comma 0 means second value, 3 comma 0 means third value, like that. Then if it is like 1 comma 1 means this point, 1 comma 2, like that we will go. Keep on. So 2 comma 0 means this value, 2 comma 1 means this value, like that it will be keep on going. For each value, the modulus will be, modulus is the z, we have fixed it like modulus as z value. The z value represents the intensity of the color, like how much intense the color should be. So color is equal to modulus. That's the third one. Then we have used geom point means it is a scatter plot. We are not. We can also plot it in the contour plot like different colors. You might have seen the heat dissipation plots in your maybe if you are from mechanical, you might have seen it in the from a heat source. The heat dissipation will be the center point will be red, and then surrounding it will be like in a gradient. So like that will be there. So here we have just represented as the point because like here the data is taken in a point by point from one point to another point. So point data. So we have taken we have did a scatter plot. So scale color gradient. We are just representing the lowest value as blue and highest value as red. Then labels as title is 2D scatter plot. That is what the title is. Then x is nothing but x value means x value is nothing but we are representing as x only, y value representing as y only. Then color as usual modulus we have taken as color. So if it is like 190 means it will take blue. Hello, Priyadarshan. Yes, sir. Okay, let's continue. Like I hope Sharmila you can able to follow right. Like I hope I'm audible and I'm just the slides, everything is visible. Just please confirm me.
Yes, sir. Yes, sir.
You can able to follow, right? You don't have any issue.
Yes, sir. No issues.
Okay, thank you. So this is how we can represent in the same data in a 2D scatter plot. So I'm just giving you essence of like how you can represent the data in other forms. That's all. So another plot which is commonly used is bar chart. Like generally we use this bar chart to substantiate or show the difference between different samples. Like Sharmila, if can you please tell me like which background you are? Like, are you from metallurgy background or mechanical civil?
Civil, sir.
Civil. Okay.
Yes, sir.
So, like if you want to show, like if you have different materials or you have made a composite of different cross sections or different compositions, and if you are representing the hardness, sorry, if you are representing a yield strength or ultimate strength data for different materials, like then we can use the basic bar chart like A, B, C, D like that. So A represents one material, B represents another material like that. So this is a basic chart like how you can do use this how you can use this chart in our language is simple like you just have to invoke data here. What I have did is like I have used the data frame technique. You can also do by from if you have CSV file you can directly invoke them. What I have did here is like using data frame I have given category as one variable. The variable has A, B, C, D, four characters. Then representing four different materials, like for example. Then values as 10, 20, 15, and 25 for each. Yeah, 10 for A, 20 for B, like that. Then for creating bar chart, first using ggplot, I have called this data, then aesthetics excess category, and y is equal to value. So that is what it will be represented, x and y values. X will be like a character ABC, and y values will be coming as the corresponding values 10, 20, 15, and 24. Then the chart type is geom bar means geometry bar means it's a bar chart. Stat is equal to identity means so this one you have to specify in case if you want to represent these values as the same values. Okay, let me make it in another way. If you don't specify this, it will normalize to some other values. Like if it will normalize to some distribution and it will plot the data. So if you give the stat equal to identity means it will take the values as it is, however you are given. 10 means it will take us 10 value only. Okay. So then labels as like these are like aesthetics only. You can add your title as basic bar chart or like whatever. Then X as category, Y as values, everything. So by doing this, also you can add colors here. Like in geom bar, if you add color is equal to blue, means it will equal to blue. The color will become blue. So all those things you can do. So this is a simple bar chart. If you want to, but most of the cases we won't be working with the simple bar chart. We might need a grouped bar chart or stacked bar chart. So for that, what you have to do is like you need to install a library using install.packages reshape tool. This is one of the library. So if you use this library, you can combine two column values into a single column value. For example, here you can see I have loaded this data frame. Using data frame, I have taken four characters A, B, C, D. For each character, I have two values, value 1 and value 2. So 10 and 20, 10 and 15 corresponds to A. Then 20 and 25 corresponds to B. 15 and 20 corresponds to C. And 25 and 30 corresponds to D, like that. So if I just plot it as it is, what will happen is like these two won't be staying, means these two won't appear together. it will just appear like some gap will be there between two plots. So that's why what I have to do is like using the function called melt. So melt, what it will do is like it will take the data, the whatever I have given input, and this id dot variables is equal to category. So whatever you have given here will be neglected. That won't be combined together. So category will be left alone. Category column will be won't be melted. It will remain as it is, but value 1 and value 2 column will be grouped together. So but you can still call value 1 separately and value 2 separately if you want in any other function also you can do. Just it will blend them together for representing into a some respective chart. Can be a grouped bar chart or grouped other charts. So for that function alone, we have to do melt data. Whatever you don't have to melt, just give that in id dot variables. Then here we have given as category. Then just as usual, give ggplot melted data underscore melted. Then aesthetics as usual, x is category, y is value, and fill is equal to variable plus geom bar chart is equal to static identity as I told you before. Position dodge. So dodge. This dodge. What is its function is? If I keep this on, the values. The graph will look like this on top. The grouped bar chart. If I keep the dodge off, like position dodge, if I don't give means by default it is not in dodge position. Then it will look like a stacked bar chart, one over another. If I give dots that on the top it will be removed and on it will be kept on the side. So that is what the major function is. You keep the position is equal to dots. If you give this command, invoke this command, it will give you the grouped bar chart. If you remove this, it will give you the stacked bar chart. So other things are as usual like title, category, and you can as I told the advantage of ggplot is first you can give this and you can see how the chart looks like, and if you feel like you want to add this labels like group to bar chart, then yeah, x is category, y is value, like that means again you can give the command and add this. Then next what you can do is like the plus, just have to use the plus symbol and you just keep on adding variable next layer. So this is all called layers. So this is basic first layer, then plus second layer, then third layer, then fourth layer. So finally what we are giving is like we are specifying for value 1 it should be in blue in color and for value 2 it should be red in color. So as I told you, just this melt will only blend the data for representing here, but when I call this value 1 means only that for value 1 variables will get the blue color value, sorry, blue color aesthetics, and value 2 will get red color. Here they won't have any issue because of the melted data. So that is only for the plotting purpose. So this is what about this is about the bar charts. Then next one is violin plot charts. Okay. Why this plot is where this plot will be helpful is like if you have if you want to represent the distribution, like how much it is varying from the mean value. So and how much it is like how the distribution is, then we can use this violin plot. See if it is similar, if it is like what is it? Yeah. So if it is having like this means, okay, first I will take the come from right side. So this one represents it has a slightly higher deviation from the mean value, but yeah, it has slightly higher deviation from the mean value, but it doesn't have much of skewness. For example, it doesn't have too much of extremities. If I have something like 10, and if I have something like if I have the mean value around 30 means, it falls between 20 and 40 like that. But if what this one represents is like the first one, A1 represent is like it has the mean value, but there are some extreme values also, like 5. In the last case, it was only 20 as a lower circuit, but here you have lower values like 5, even 10 also you have. So that is what represents. And the green one represent the variations are very less like that. So that's where this violin plot is being used. I can show you one example here. Like here, we are just trying to represent the tensile strength distribution of alloys. We have got three alloys A, B, C. So one alloy is having the mean value close to 200. The another alloy is having the mean value close to 225. But with a higher distribution, like you can see, right? It can vary from the range more than 270 to 260 to even 180. But in the alloy A, the distribution length is very less. Then alloy C is having slightly higher strength, tensile strength, which ranges from uh, around 210 to even 270 something. So this is how you can represent so you can use this. You can use this plot to represent different materials and their properties also. So for this, okay, what we have done here is like using data frame. We have given alloy is equal to ABC, and we have rep means it will repeat ABC, ABC, ABC like that for 50 times. So why it is doing so is like we are just trying to give values to all the like we have taken like around 50 samples. For that sample, we are plotting this. For each sample, we have 50 data sets. So that's what next one. What we are doing is like tensile underscore strength of C of R normal means you are creating normally distributed random variables 50 for A with mean 200 and standard deviation 10. Then you are creating another random variable with mean 50. Sorry, yeah, with 50 variables with 50 numbers with mean 220 and standard deviation 15. So you can see that's why it is having higher standard deviation percent alloy B. Then for C, alloy C, we are having mean 240. That's why it is placed at a slightly higher position because of 240, and it has standard deviation of 12. So that's why we can see the shape difference, right? Here it is like short, which means like their standard deviation is less. This is lengthy, elongated, which means the standard deviation is high, like 15. Then it is slightly elongated, having standard deviation 4. Then as usual, ggplot, you have to invoke the data which you are going to do. Then aesthetics, what you have to represent in X, what you have to represent in Y, you have to specify. Then geom violin, then the titles. So since it looks like the violin, which is generally called as violin plot. I hope this will help you. Like if you want to represent some of your data, you can try this. Then faceted scatter plot. This plot again, it is similar to violin plot. Just to represent the data, like if it is too much of having upper and lower, means it is like distributed. Their standard deviation is high. If it is concentrated to one point, means that its standard deviation is less. So here so in this way we can take if you have three alloys and they have different ductility or Young's modulus or something like that, means you can use this and tell which test data is reliable. If it is concentrated to one single line or point, means it is more reliable compared to higher distributed. So here just you have to tell like geom point, and then you have to use another uh, uh, syntax called chase facet underscore wrap. which one you have to wrap is the category. The category one, you have to wrap it like A, B, C should be coming. The wrap means you have to bring them together. So A plot, B plot, and C plot will be brought together. Otherwise, if you just give without this means only the A plot will be plotted or B plot will be plotted based on the first 100 values. So, yes. So another plot is the line plot. So this is a very basic plot and we will be using it more commonly. So for example, if you want to represent your stress strain curves, all those things will come in the line plot. So here we are just invoking, they are just trying to represent the hardness value with respect to depth. For example, on the top, they have did some heat treatment. They want to see how much is the hardness over the depth value because of the heat treatment. So first they are seeing at zero level, they are having around 180, 180 Vickers hardness or hardness, whatever, can be Rockwell or Vickers or even Brinell. So let's take like 180 means it should be something like Vickers hardness generally, because Brinell will be different. Rockwell maximum is 60 or 65, so it can be it can be Vickers hardness. So it is varying. You can see like it is increasing exponentially with increase in depth. So that is because like they have already written the program in such a way that they have given depth should be varying from 0 to 10 but with the increment of 0.1. So 0, 0.1, 0.2 like that up to 10 it will be variables will be generated. And hardness they have related as 200 minus 20 into exponential of minus 0.5 into the sequence 0, 10 by 0.1. So using this, this is the equation. In this equation, hardness will be hardness is plotted here. For that, you can see, okay, the hardness is being stored. Hardness values are being stored in this. Then when we are plotting, we give x and excess depth and y as hardness in the y-axis, and geom line means it will be plotting the line plot. Then we can specify the labels like title, hardness profile, x depth, y hardness like that. So that's it. So these are like 2D plots, like whatever. Sorry, you are having one variable and one what is that? In one independent variable and dependent variable. Here, independent variable is depth and dependent variable is hardness. But here, if you see, this is a 2D plot. As I told you, like the heat distribution. In case if you have a laser, like if you work in additive manufacturing, you will know. If you have a laser will be melting the material. So center, it will have a Gaussian profile. So Gaussian profile means it will be at the center, the heat will be high. On the sides, it will be decreasing. It's similar to the standard normal distribution. So here just they are trying to represent the heat distribution near the heat source. So if you want me to explain means first they are taking the x value from minus 10 to plus 10 with increment of 0.1. Similarly, they are taking y values from minus 10 to plus 10 with the increment of 0.1, and they are specifying the z value, that is the heat intensity value for each outer means it will perform the function this 100 into exponential of this function, and it will return the value to the z. So that is what it is going to do. So based on that, it will store for each points, it will store the values. Then if you see in ggplot, we are using the geometry tile. So it is used for a tile function will have for each and every point it will have a tile. Tile means right, like as we use in our homes. Each tile will have one color like blue, red. Blue means blue. Then when it is coming close, it is turning into red because of the higher heat dissipation. That's higher heat intensity. So using tile, we will give fill gradient as low value as blue and high value as red. So based on that, it will result in this heat distribution profile. This is a 2D plot where you have two independent variable and one dependent variable. Two independent variables are x and y. Dependent variable is z. That is the heat intensity. So with this, I just wanted to give you a brief introduction about this ggplot and what are the various plots you can do. Like if you are into research, means there is one more tool called Origin. I don't know how many of you are aware of it. Origin is like it gives all these things in a what to say in a user-friendly way. Like you don't have to program that. It's like Excel only. You have to do a lot of plot. You can do all the plottings in that software. But one drawback is like if I want to represent the same thing to another plot, means I don't have much options there. I can just copy the format and paste format there. But still, this one, if I all I have to do is like I just have to change the input. If I change the input with the similar layout, everything, my another next result will be plotted and it is ready for representation. So this is the advantage of using our language for plotting the things. Yeah. Literally, like if you invoke your input file, it can do even thousands of such plotting without your intervention. That's the biggest advantage. Okay, moving on to the second question of this assignment. Using R, generate a summary report of hardness data from question 1. Which of the following options corresponds to a report you have generated? Okay, let me let me tell you like how to get the summary report. It is just simple. First, you have to have a value for any variable. Like we are reading the CSV file modulus hardness, and we are invoking all those values to x. And as you know, x and first column corresponds to modulus, and second column corresponds to the hardness. So we are generating summary the respective variable, like here x uh, in the box bracket comma 1 means it will take the column 1. Column 1 is modulus. So you can see the minimum value of the modulus is 187. First quartile, which means like 25% of the data is within this. The 25% is below this. Like 205.3 median. Median is like 50%. 50% of the data will fall under this. 215. Then third quartile is 220. Then maximum whatever the extremity is the 238.2. So and the another meaningful result here is mean is 213.4. So this is what you can, this is how you have to read it. I will explain what is first quartile, third quartile, everything when I am discussing the box and whiskers plot. Because it is easy to visualize using that plot compared to just I am telling like whatever the value is. Then hardness. Okay. So hardness is plotted in the second column, and if you could give comma 2 means it will take only the second. It will take the second column and give the summary report. So the syntax is nothing but summary x or whatever variable. Like if you have stored it as modulus means modulus box bracket comma 1 for column. If you don't have any, if you are directly invoking, like for example, Unix, we give it like concatenation of C of 1 to 100 means it will take first 100 values. So in this case, if I want to create a summary of x is enough. That's all. It will give you the summary. Since you have in that form of matrix, that's why you are representing like x of comma 1, x of comma 2 like that. Okay. So moving on to the third question. So which of the following command will not give a property-based report of the given data in R? So property-based report means it will give you there are two things like property-based report and rank-based report. Rank-based reports are like if you take the interquartile, first quartile, third quartile, all those things are rank based reports. I will tell you like when I'm discussing about the first quartile, second, third quartile, all those things. Whenever you take the whole values and if you are considering one property of it, for example, mean means it's a central tendency. Central tendency is a property. So, which means like you are representing a property. So, it is a property based report. But if you take first quartile or third quartile, it is not giving any property. Rather, it is telling like a given uh, or a section of data which fall in this category, a section of data which fall under the other category, like that only it gives. Those are called rank based reports. But property based report means it will have a property. Central tendency is a property. So mean, median, mode, standard deviation, variance, all are property based reports only. Because mean represents the average value, median is like center value, mode is like how frequently the one value repeats. Standard deviation is like standard deviation and variance represents the deviation from the central tendency. So all these things are property based reports only. But as per R, there is no command which gives the direct mode value. For example, if you give I'm invoking a variable mode val is my variable where I give values like 1, 2, 3, 4, 4, 5, 5, 6, 6, 6, 6, and 7. And if I give mean of mode value means I will get the mean value of 4.58. Median means I will get median. Standard deviation means I will get standard deviation. Variance means I will get variance. But if I give mode value means I won't get any result. I'll just get the numeric, which means like there is no function which directly gives the mode value of a given variable. So for which of the following command will not give a property based report is the command is mode within round bracket doesn't give you a property based report, but mode itself is a property based one. I hope this should be clear. So moving on to the next, before moving to the next question, I want you to be aware of box and viscous plot. So what is this box and viscous plot? Meaning the box in the plot represents the interquartile range, which means like the center 50% of data where it lies. And then this viscous represents the extreme, the range, the lower value to higher value. Then this points represents the outliers. Outliers means which are like, for example, if you consider this data, right, it starts from 10 to 50. You can see from 10 to 50, it looks a proper range. But suddenly there's a value called 100 that is not even close to whatever we are looking at, right? Within the range of 10 to 50. So these are called outliers. They will be represented as dots, or like whatever circles or anything like that. They will be represented. So what is the use of box and viscous plot is like from one plot you can from one plot you can know what is the minimum value. In this case, the minimum value is 10, which you can see from the lower whisker. The maximum value is like 50. Then outlier also you can see the 100 is outlier using this point. Then median is represented with this dark line. So median lies somewhere between 30 to 40, 35 to 40. Yeah. So if you want to know the exact value, if you take mean of data, you will get the mean value. Then median value. I'm discussing. Okay. So box and viscous plot. Okay, first quartile is like 25% of the data will be within this. Then third quartile is like 70% of the data will be below this. So that is what the third quartile is. Then if you subtract the Q3 minus Q1, we will get the interquartile range, IQR, people call it as. So the simple thing is like if you have a data set, it just need a one single data set. Doesn't need X, Y, something like that. Just X is enough to represent this. So even hardness can be best represented in this. Like if you have taken some 100 values, means you can see what is the minimum value, what is the maximum value, or what is the interquartile range, what is the mean value. So this plot is robust because the extreme values are neglected here. If you calculate a mean, for example, we have seen this bar chart, right? In bar chart, um, one second, let me still plot a sample bar chart. Give me a second. If we plot a bar chart like this, so I hope you are aware of this error bars which they give like this. So bar charts are sensitive to extreme values because we are taking an average of it and we are representing the yield strength. Like so suppose this is yield strength, this is alloy A, B, C means if you have the when you do tensile test and when you get if you repeat for three specimens and one is having 180 MPa as hardness, the other one is having sorry, not hardness, I mean yield strength, then 200 MPa as yield strength. If the other one is having 300 MPa means the result will be significantly influenced by this 300, the extreme values 300 and 180. So when you take the average of this and you represent, the error bar will be very high. So, but if you take this box and whiskers plot, right, like it tells you clearly like where the mean value lies. It doesn't care about the extremities like this outliers, right? These won't affect the box and whiskers plot because they are clearly indicated within this. Okay. So, as I told, using box and whiskers plot, we can get minimum value, first quartile, median, third quartile, and minimum maximum values. In one plot itself, we can see all the things. Okay, let me tell you like how to plot this. Just box plot, and if you provide the variable, the box plot will be generated. So within that, if you give main means the title, you can write using the main, then X lab, Y lab. This is apart from ggplot I'm telling. If you directly want to plot means just a comma, use main format, right? Main is equal to, should give some title, should be represented, then comma. You can represent X lab is equal to data, Y lab is equal to values here. You can see from this. So yeah. Here I have taken the data from 10 to 100 and 100 is like not even close to other values, so it is an outlier, and data is plotted. Mean value is somewhere between 35 to 40. Yeah. So this is the advantage of box and whiskers plot. Just I wanted to tell you this. Then just want you to know like what is the interquartile range. As I told, it is a rank based one. It is not property based because it gives the range where the values lies. It doesn't tell like from any standard point like median for median how it is varying. It doesn't tell that. It is just telling 50 how much how many values fall. What are the 50% of the data is lying in which range? That is what it tells. Okay, here if you see, they have compared the three alloys. Like in this case, we can consider like alloys and their hardness values or hardness values. We can take this, so we can compare it in this way. If I have you can see like here it has outlier at close to 5, and it has the outlier at the upper circuit close to 18. Apart from that, the mean values are close to 15 here. The mean values are close to 12, 11.9 or 12 here. The mean values are close to 10 here. That's all. Okay, coming to the fourth question. Suppose you want to plot a box plot as shown in the figure below. So, in the figure below, they have told it as they have given it with a they have given it with a notch. So, just to tell you, like, what is the question? And they are asking like which of the code snippet will give you the correct answer. So box plot of hardness, like let me directly go to the answer. So all the commands, all the program will give you the box plot. But if you take the first plot, they have given notch as false. Notch is one of the element of this box plot. If you give notch is equal to true, you will get notch. If you give notch is equal to false, default it is false only. If you don't give anything or notch is equal to false means notch won't come into the picture. Okay. Then other things are like same. Okay. One more thing I wanted to tell you is like they have taken the hardness value from that first file. How they have taken is like hardness is equal to nano data underscore hardness.gp. Hardness. Okay, I think it's a separate file. So nano data is the file name. From that, hardness is one of the column. They have taken that using, if you use this dollar symbol means you are representing one column. Like hardness not GPA column alone, you can invoke the hardness and you can do the post processing like box plot or what are plot is required you can do. So here notch is false, so no notch. Then second one, box plot of hardness, again there is no, by default if you don't give anything about the notch means notch false is the default, so it is also not representing your requirement. So third is they have represented they have given other things, aesthetics like color orange, border brown like that, but it doesn't represent our plot. So yeah. Okay. Here, when you give notch is equal to true, you are getting this notch. So that is what the answer is. Notch is equal to true should be there in your program. You give that, it will be given. So it gives 95% of the confidence index to that. If you take any data within that notch, it will have 95% confidence index. That is what that represents. That's all. Just wanted to tell you like how each and every when you run this course, what results you will be getting for each. So moving on to the fifth question, which of the following strips will plot the scatter plot of hardness data and also draw a line along the mean value of hardness as shown below. Okay. First, as you all know, like scatter plot, we can just plot it by default. If you give plot x means it will do scatter plot only. So you don't have to if you don't specify anything other like plot line underscore line anything like that means by default it will plot only the scatter plot. So here they are just drawing a line. This represents the mean. So that is what the question is like. A line is drawn along the mean value. So let me tell you like what are all the other possibilities. Okay, first let me go through the options. X is like define hardness dataset. You can give whatever hardness dataset you want, and then if you give plot X, this will be plotted. AB line above the line, this H is equal to H means it is H. You didn't specify any value to this, so it doesn't come in the mean value. So if you specify something like 6 means directly a line will be drawn. H means you mean horizontal. Sorry, I didn't mention that, right? So H is horizontal A means it's customizable, then V means vertical. So, okay, let me show you. Here, to create a scatter plot, just I have to add a line in the plot. So, for that, I'm using create a scatter plot with the x value ranging from 1 to 10. You can see here, x value ranging from 1 to 10, y value again ranging from 1 to 10. So add a vertical line at x is equal to 7. For that, what I'm doing is like first I'm plotting 1 to 10, 1 to 10. Then I'm drawing the add a vertical line at x is equal to 7. For that, AB line V is equal to 7. If I give h is equal to 7, horizontal line will be drawn at 7. Here I am giving V is equal to 7. Color of that line is blue and line type is 3. 3 is dotted. If you don't specify anything by default, line type is 1, that is bold line. So each line type, in last live session, I have told what each line type corresponds to. Maybe like you can go through that. So another type is customizable. For that custom line, what I can do is like as usual, I have created a plot. Then I'm drawing a custom line with intercept 2 and slope 0.5. So if you use A, right, A is custom line. A is equal to 2 means the intercept is 2 and the slope is 0.5. So it is moving with 0.5 slope. Then color of that is green and line type is 1. By default, it is 1 only. You don't have to specify that. So it will draw a line with intercept 2 and slope 0.5. So this is positive slope, so it is increasing. Okay, if you go back to the question and if you see the thing, uh, as I told, it's a custom line. A is equal to mean x means the mean value is something around 6 means if you should also specify if you are using the custom line means you should specify the intercept A and slope value B. Then only it will become complete. If you don't specify that, then it is not a complete one. So the first one is wrong because you didn't specify the h value. Second one is wrong because you didn't specify the slope value. And again, okay, so you didn't specify the slope value. Okay, third one, if you see, they have taken the h value as which is equal to mean of. So mean value will be taken to h, and you are representing h is equal to h. Now h has a value, so a line will be drawn. So this is correct. And second also, like sorry, last one also, if you see plot x, AB line h is equal to mean of x. So here also you have the mean value invoked to h. So this is also correct. Both ways you can represent this. That is bringing this to here. That is the only change which you have made from this to this. So both are correct. So maybe moving on to sixth question. Sixth question is like they are using the fit distribution plus library. Using fit distribution plus library and second. Okay, and descriptive distribution command calculate the skewness and kurtosis of the hardness data. Okay, so what do you mean by skewness and kurtosis? First, we have to understand this before going on to the things. The skewness means how the curve is deviating from the mean or normal distribution. For example, I have a distribution like this, the center. This is distribution. If I have a skewness, means be like this. Will be towards the right side or towards the left side. So this is called tail. So one is negatively skewed and positively skewed. So if it is like close to 1 means the skewness is less. If it is negative means negative skewness and positive means positive skewness. Sorry, 1 second. Just let me confirm this. Okay, sorry for the wrong information. The skewness is one means it is positively skewed. If it is like um yeah, if it is positive means the tail will be on the right side. Uh, one second. Yeah. So skewness should be zero. If skewness is zero, it is perfectly symmetric. Which is like positive means positively skewed. If it is zero means negatively skewed. So the skew is there on the this is positive skew. This negative skew. The skew. The tail is there on the left side. It is negatively skewed. The tail is there on the right side. It is positively skewed. So this can be obtained from this fit distribution plus. The fit distribution plus library has a lot of other functions like fitting a data set to a, for example, if you take some from n population, if you take the height of the population, if you are or for example, since you are from civil, we can take like you have we have taken ultimate strength of material from 100 samples, like in a quality line. So, and you are trying to represent them in the standard normal distribution. So, this tells that it is deviating like some 0.2% or 0.2% it is deviating like that. So but if you want to confirm, because it is like some huge data, for like 100 data you can calculate. If it is some 1000 data, how you will tell like it is exactly following the standard normal distribution or anything like that. So for that, what you can do is like you using fit distribution plus from fit distribution plus library, we can use a function called fit, and you can use this use your data, like whatever you have the input file is, using that you can check the confidence index. It is like close to 1, then it is like 100% matching with um standard normal distribution. If it is less than that, like nearly equal to 0.1 or 0.3 or 5 means it is having poor fit. So all those things can be done using the fit distribution plus from using fit distribution plus library. But we are only doing the descriptive distribution. Using descriptive distribution command, we can get the skewness, kurtosis, all those data. So okay, directly diving on to this question, what we have to do is like first you have to install the package. Most of you might not have this packages predefined. So install dot packages fit distribution plus, then library, you just load that fit distribution plus, then okay, here I have stored it in a hardness variable. So this DEST hardness. When I do that, I will get this summary statistics. So how it is different from summary is, in summary we will get minimum value, first quartile, mean, median, and third quartile, and maximum values. But you will get standard deviation, skewness, kurtosis, all much more statistical summary you will get it. So okay, I told you about the skewness, but kurtosis is like second. Kurtosis is used to describe the degree of tailness, like or how that degree of tail is. So If a distribution is having higher kurtosis, then the tail is like higher than the normal distribution. If the kurtosis is like lower, means it has thinner tail. Um, than those of this normal distributions, which has fewer outliers. Like if the kurtosis is more, it tells that it has higher this outliers. Outliers means extremities. If the kurtosis is less, it has lesser extremities. So it's better to have lower kurtosis to match to the. So you have got the skewness and kurtosis from this. So with this, we can answer this question, sixth question. So moving on to the seventh question. Which of the following options gives the correct values of interquartile range for hardness and modulus, respectively? So they are asking you to calculate the interquartile range for hardness and modulus. For interquartile range, easiest way we can do is like using summary. Because using descriptive distribution function command, you can get the skewness, kurtosis, and all those things, standard deviation. But if you want this interquartile range and maximum value, minimum value, you can use summary directly. As we have done before, just a summary on x of comma 1 means it will take it from the modulus, because they have told from question 1. In question 1, first column represents the modulus and second column represents the hardness value. So from this you can get the minimum. Okay, first they are asking the interquartile range for the hardness. So from this you can know like the how much is the interquartile range. Just to you can just type just type IQR of x of 1. It means you can calculate from this. We can subtract the third quartile and first quartile, and you can get this value. Otherwise, I can directly use this command IQR interquartile range of x. As you mentioned it for summary, you can do this and you can directly get this value 15.28. Otherwise, you can subtract and get this value. Similar thing can be done for the hardness also. This is all for the seventh question. Let's move to the eighth question. Considering the following data on density and electrical conductivity of water and brine solution for two density ranges, one set of data is where density is greater than 1. You can see half of this data is having higher density, which is more than 1, and another set of data has density less than 1. So yeah, the lower part of this is less than 1. Okay, this is reported in from journal. So sorry, they have given a file also. I hope you would have got it. So in that file, they are asking us to which of the following scripts will get the data points where density is less than 1 and plot conductivity against density. First, what you have to do is like we have to segregate those values which is having density less than 1, this bottom value. Then we have to plot those density values against the conductivity. So just they want to know how the conductivity varies with respect to the density of the material. So for that, first we read the .csv file. In that density, conductivity, both are there in the two columns. So first we are taking the density in the first column, and yeah, first column is having the characters high, low, all those things. Second column is having density. The third column is having conductivity. So first what we are doing is like using grep function. Grep get rep function. What it will do is like it will compare the string, and whatever the string value string which is matching, it will return the respective number. So for example, here low means it will calculate the number like 1, 2, 3, 6, 7. So ninth one. So from 9 to whatever 18. So it will compare this. It will compare from 1 to 18 also. So it will compare, and whichever is having low, that alone it will segregate, and it will store it in I1, because we are using this command. So which means like the respective values will be stored. It will be compared in the first column only, because we are giving the condition as y of 1. 1 means this first column only it will compare. It won't go to this density or conductivity column, and it will store them in I1. Then what? So, okay, the first thing is done. They are asking which of the following strips will get the data points where density is less than 1. That is done. Now we have to plot it against the conductivity. So for that, what we are doing is, so plot y of I1 comma 2. I1 comma 2 means it will take this um, yeah, it will take from I1, it will take the second column. So in the second column is the density. So the lower density values will be plotted in x-axis. Then for I1, the third column is the respective conductivities. Then the conductivity will be plotted in y-axis. Then they are giving x labeling as density, y labeling as conductivity, and that's how it will be plotted. So the major thing which you have to understand is the function of this graph, and how we can segregate this. So this will be helpful, because like if you are this is very basic thing in schools, because like if you have a group of people, and if you want to separate your students with respect to their grades. So that time what you can do is like in the grade some column will be like grade will be there in the Excel. That directly you can invoke that Excel file in CSV format, and you can segregate the people who are having A grade, having B grade, like that you can segregate, and you can print them separately, like people who are having A grade separately, B grade separately. So that can also be done. So that's an advantage. So this is a detailed introduction about this grep function. It searches for the patterns with character vectors or strings. So, for example, here character means it is like ABC. So strings means it can be like now we have seen, right, high, low, all those things are strings. So first one represents the pattern to be matched. Here, like we have fitted like low, high. Then from which um, variable the searching has to be done. So you can directly mention x or x of 1 comma 1 means first column will be searched like that. Then ignore case means whether it is case sensitive or not. If you don't want to be, sometimes you will be by mistake will represent the first value as LOW, but over the time you will represent everything as in the lower characters. So if you feel like the case sensitive should be off means ignore dot case is equal to true. If you mention true means the case sensitive will be off, and value if true means it will return the matching elements. For example, um, I will just check that. Oh, okay. If I have a banana, apple, an apple. If I give the pattern as TPL means TPL, and if I give value is equal to false means it will return as the output will be written as 2 comma 2 and 3. So which means like this 2 and 3 third strings are matching with my pattern. But if I keep this value is equal to true means it will return the exact values. For example, it will return as apple comma pineapple. It will return the value itself. So for that you have to turn the value true. So that is the syntax for Jira. Ninth question. Consider the density versus conductivity dataset from question 8. Suppose we want to generate two plots of conductivity against density such that the plot on the left only shows the density values less than 1 and the plot on the right side shows the density values greater than 1. So which of the following scripts will make the plot? Okay, so it is simple. Like last time itself we have segregated the lower values and higher values. We will do it again. So if you consider, if you want to store the lower values in one means, what you have to do is like as we did before, zero low, the string which has to be pattern which has to be matched is low, and y is the variable. Y of 1 means it will search from that first column which is having high low values, and it will store them in I1. Whatever is having low is stored in I1. Whatever is having high in that column, it is stored in I2. So now I1 will have the lower part of this. Yeah, I1 will have this values, this value. Then I2 will have these values. So now when you give plot of a plot, okay, for plotting them side by side, you have to use this command. Uh, Multifunction row. So PAR multifunction row is equal to C of 1 comma 2. 1 comma 2 means it represents two columns. One is single row and two columns, like that. If you give C of 2 comma 1 means your plot will be represented like this, one by one. Two rows, I mean two rows and one column, like that. So based on your command, it will be generated. First, if you give P or M of row is equal to C of 1 comma 2, and later if you give plot of 1 comma 2 and I1 comma 3 means the lower part will be first plotted here. Then once you're done with this command, it will first this will plot this. Then once you write this command and if you're done with this, run this command, it will plot the second plot on the side. So that's all. Function, what you have to understand is this function. What is the use of this function? Okay, what are the x and y axis of the Cullen and Frey graph? So this is the Cullen and Frey graph. So the x and y axis of this Cullen and Frey graph represents the square of skewness and the kurtosis. So this Cullen and Frey graph was used to it used to compare the skewness and kurtosis in one file in Tableau. So whatever just fall within that this gray region is taken as the um, follows within the normal distribution. So this is to do with all the 10 questions are done. So if you have any doubts, we can now ask. We can discuss. You have any questions? No. Sharmila, do you have any doubts? Sharmila, are you there? Sharmila? If you have any further doubts, means this is my mail ID. You can write to this mail ID. I will respond. Whichever questions you have doubt, you can just write it to this mail ID, and I will personally discuss with you based on the time available. If you don't have any doubt, so you can leave. Thank you. Element free graph is when you plot your squareness of curtices and squareness of this pair of squares and curtices, and if your data fall under any given region, for example, gamma or log normal distribution or beta distribution, exponential, then we can tell like the closeness of your means your data is close to the fit of the particular distribution, gamma distribution or log norm beta distribution. So or uniform distribution. So it can be used to identify the closeness to any distribution. Closeness of our data to any distribution can be identified using the Cullen and Frey graph.